All right, if you're a seasoned networking pro, I'm talking you've got your CCIE, you live and breathe routing, switching, and firewalls, this is for you. Because when you step into the AWS cloud, the whole landscape changes. So today, we're doing the Expert's Translation Guide. We're going to map all those hard-earned skills you have directly to the world of AWS networking. Let's dive in. So here's the big question, right? Do all those years of CLI commands and troubleshooting protocols and racking hardware, does it all translate one-to-one? I mean, you've got the concepts down cold, no question. But the way it's all implemented in the cloud, that's a whole different ballgame. We're going to move pretty fast here, so we're skipping all the basic stuff you already know. Instead, we're going to focus on the specific abstractions and really the mental model shifts that trip up even the pros. So yeah, let's put those skills to the test. So here's our game plan. We'll start with that big conceptual shift. Then we'll translate your core knowledge from LAN to VPC. After that, we'll actually build a secure VPC, test the traffic flow, cover the top gotchas you need to avoid, and finally, we'll look at what you've mastered. The very first thing you have to wrap your head around is that we're moving from a physical world to a world of pure software-defined abstraction. You know, you're used to getting on the CLI of a router or a switch. In AWS, you're not doing that. You're manipulating this massive programmable fabric using APIs. The core concepts are still there, but the layer you actually interact with, it's fundamentally different. Okay, so let's get to the heart of it. This section right here is your translation key. We're going to map the terms and devices you know and love to their AWS counterparts. This is really where we build that new mental model for the cloud. Now, this slide here highlights one of the biggest initial hurdles. In your data center, you can stretch a VLAN across multiple racks, maybe even across buildings, right? Well, in AWS, a subnet, which is its closest equivalent, is strictly, and I mean strictly confined to a single availability zone. You absolutely cannot stretch a subnet across AZs. And that has huge implications for how you design for high availability. Think of this table as your Rosetta Stone. A VRF, that's basically a VPC. A firewall, well, it's kind of split into two things, the stateful security group at the instance level and the stateless network ACL at the subnet level. And your router? It gets replaced by a simple route table. The most crucial difference, though, is what's not there. You get no CLI access, no BGP or OSPF to configure, and you can't check ARP or MAC tables. It is all managed for you. So here it is. This is the key mental shift. You have to stop picturing physical boxes and cables. Instead, I want you to think of a VPC as a giant, invisible, programmable Layer 3 fabric. By default, every single instance can talk to every other instance, almost like they're all plugged into one giant, continent-spanning router that you control completely through configuration. All right, enough theory. Let's get our hands dirty and see how this actually works. We're going to build the most common, the most essential AWS network blueprint there is, a secure VPC with separate public and private subnets. First, we lay the foundation. We create our VPC, that's our isolated virtual network, our VRF. Then, we just carve out two subnets from our big address block, one that we're going to call public and one that's going to be private. Finally, we create an internet gateway, or IGW, and we attach it to our VPC. You can think of this gateway as the front door to the outside world. Okay, now this is a really critical step. A subnet isn't public just because we give it that name. It only becomes public when its associated route table actually has a path to the internet. And we do that by adding a default route, the quad 0 route, that points all outbound traffic to that internet gateway we just created. It's this one single line that makes all the difference. Next, we're going to create our instance-level firewalls, which are called security groups. We'll make one for our public instance that allows SSHN from our IP address, and another one for our private instance that will only allow traffic from our public instance. Then we just launch our two virtual servers, and we make sure to place each one in its correct subnet with its assigned security group. Any network architect knows a build isn't complete until it's been verified. So now we're going to run 3 essential tests to confirm that our traffic is flowing exactly the way we designed it to. Okay, test number 1. This is all about our public-facing connectivity. From our own computer, can we actually open an SSH session with that public EC2 instance? This is going to test the entire inbound path. And we have success. It works. This confirms that our internet gateway is attached right, our public route table is doing its job, and our public security group is correctly configured to let our SSH connection come through. So test 2 is about the internal path. Now that we're inside the public instance, can we reach the private instance from there? This is going to validate our east-west traffic flow and our internal security rules. And that's another success. This tells us two things. One, that the implicit routing inside the VPC is working perfectly, and more importantly, that our security group rule allowing the public instance to talk to the private instance is functioning just as we intended. And now for the final, and honestly, the most revealing test. From inside our private instance, which has no public IP and no direct route out, can it initiate a connection to the internet? Can we curl Google? And the results is connection timed out. And believe it or not, this is a success. This failure is the proof in the pudding that our private subnet is truly private. It's totally isolated from inbound connections, and right now it has no path to get out. Our security posture is exactly what we designed. Okay, let's wrap up the practical side of this with some high-value intel. These are the most common traps that network pros fall into when they first get started with AWS. If you can get these right, you're going to be ahead of 90% of the people starting out. Let's just run through these quick myth busters. Number 1, a subnet cannot span AZs, period. 2, a security group is stateful, which means return traffic is automatically allowed. 3, a public subnet is just a name until you give it that default route to the IGW. And finally, a private subnet can't just magically reach the internet. It's going to need some help. So in just the last few minutes, you've fundamentally updated your networking mental model for the cloud. Let's do a quick recap of the powerful new concepts you've got under your belt now. You've now officially translated your core skills. You know how to design a foundational cloud network, you know how to control traffic flow with routing and stateful firewalls, and you can confidently create secure, isolated network segments. You've gone way beyond just knowing the names of the services to really understanding how they all work together to form this coherent, secure system. So let's end on this. Your private instances are secure. That's great. But they're also completely isolated, which means they can't download security patches or software updates. So what's the missing piece? How do you let them initiate outbound connections to the internet without exposing them to any inbound threats? Well, that is the next step in your AWS networking journey.